Hello everyone and welcome to Van Tech Corner. In this video, we will take a look at the ZimaBoard 2, the second generation single-board x86 server from IceWhale. 3 years ago, I reviewed the third generation ZimaBoard. At that time, it was an interesting option for small home lab projects such as Proxmox, NAS, Docker or open source RouterOS with OpenWrt or pfSense. Now, with the ZimaBoard 2, everything has been upgraded. The CPU is more powerful, the memory is double, and the I/O is much more flexible. Let's check it out. The ZimaBoard 2 I got is the 1664 model. It comes with the quad-core Intel N150 CPU and 16GB of LPDDR5X RAM. It also has 64GB of eMMC storage, and we can easily extend the storage with two SATA 3 ports. For networking, the ZimaBoard 2 had two 2.5GB Ethernet ports, but that's not all. You can extend the connectivity with the PCIe 3.0x4 slot. It can be a 2.5GB Ethernet adapter, an NVIDIA GPU, AI accelerator card, or 10GB Ethernet adapter, or any PCIe adapters you can think of. Of course, we do have two USB 3.0 ports to connect the keyboard, mouse, or USB flash drive, and a DC barrel jack to power on the device. Display ports is rarely used when it comes to server. However, we do have a mini DP 1.4 port to attach monitor. This will be useful when installing OS with GUI or simply debugging with mouse and keyboard. On the rear side of the ZimaBoard 2, we do have a small LED indicator. This will indicate power and it is in red color. The second generation of ZimaBoard now supports a 4-pin cooling fan besides the passive metal casing. It is recommended to install this fan to keep the device temperatures in control if you are going to run it 24/7. ZimaBoard 2 ships with ZimaOS, an operating system developed by IceWhale as the next step beyond CastOS. Unlike CastOS, which is mainly based on Docker, ZimaOS is an actual OS, inherited the feature-rich Docker App Store and user-friendly GUI from CastOS. ZimaOS comes with features that CastOS doesn't have, such as ZVM, Zima Virtual Machine, which allow you to run Windows and Linux machines for lightweight virtualization. You can also manage the storage, set up RAIDs in just a few clicks using the web UI. For the first time, ZimaOS introduced the backup app, which simplified the 3-2-1 backup rule. The app lets you mount remote storage from Google Drive, Dropbox, OneDrive, etc. Once the storage setup is ready, you just need to tell the app what to backup and where to backup, and it will get the job done. Not forget to mention that all the applications on the App Store either come from IceWhale or contributed by the community works well on ZimaBoard. Sync photo with image, media server with Jellyfin, network video recording with Kerberos, home assistance for smart home, Pi-hole for DNS control and edge blocking, etc. The list is long and you can explore it further on your own. One of the key features of ZimaOS is the Zima client application. It is available on iOS, Android, Windows, and macOS. It allows you to connect the ZimaBoard 2 from anywhere with the Zima device ID. Once it is open, the client automatically discovers your device, lets you manage files, monitor system status, and even mount network rights. The remote connection is based on zero-type VPN. The data is end-to-end encrypted, and most importantly, no port forwarding or DNS is required to get it work. The list of the features is still going on. You can check out further information on the ZimaOS website. Now, let's have a quick look at the file transferring speed of the ZimaBoard 2. I set up a RAID 1 storage with two 212GB SSD. The ZimaBoard 2 is directly connected to the PC via Ethernet cable. The link speed is 2.5 gigabit per second. In this test, I'm copying files from my NVMe SSD to the ZimaBoard 2 SSD storage. We can see that the recorded speed is around 283 MB per second. This speed remains stable through the copy process. I also tested the read and write speed with the Crystal Smart application. Here we can see that the sequential read and write speed is up to 293 MB per second, and the random 4K read is 137, where the random 4K write is around 79 MB per second. The random 4K read and write with 1 thread 1 queue is around 11 for read and 9 for write. I also tested the Zima virtual machine, and in this test I set up an Ubuntu virtual machine and it worked just fine. Windows 10 and Windows 11 is also supported, and in this test you can see that I have a fully working Windows virtual machines running on the ZimaBoard 2. ZimaOS comes with pre-installed Intel UHD driver, so hardware encoding works out of the box with Jellyfin. You just need to go to the playback transcoding and enable hardware encoding, and it will work just fine. In this test, we can see that the GPU is being utilized to process the video instead of the CPU. Since the electricity cost is increasing, let's do a simple power consumption test. For this test, I used the official 12V 5A power supply provided with the ZimaBoard 2. With 2 SSD attached and some lightweight container running, the power consumption during idle is 6.5 to 7.5 watt. With the CPU load at 20%, the power consumption is at 8 to 9 watt. With the CPU fully loaded together with this read and write operation, the maximum power consumption recorded is 21 watt. The ZimaBoard 2 has a dashboard for CPU utilization and power consumption, but this is not really accurate. For example, when the actual power consumption is 20 watt, the dashboard only shows 12.5 watt. During idle, it says the power consumption is 3 watt, but the actual number is 7 watt. So, the power consumption on the dashboard is just for references. Alright, so that should be all for this video. In the next video, we will have further testing such as OpenWrt on the ZimaBoard 2 or Proxmox on the ZimaBoard 2. Thanks everyone for watching and see you in the next video.